Okay, so today we're going to be working the parallel, perpendicular, and transversal lines review for your test tomorrow. Okay, so the first couple of problems want you to classify the angles as alternate interior, exterior, corresponding, same side interior, same side exterior, vertical linear pair, or none. Okay, so the first one is asking us to compare 1 and 4. So these angles, let me zoom in a little bit. Okay, they're close to each other, they share a vertex, and they're opposite each other. So that means that these are vertical angles. Okay. Number 2 is asking us to look at 13 and 14. So once again, these angles share a vertex and a side. They're adjacent to each other and they form a line. So these are a linear pair. Okay. Number 3 is asking us to compare 4 and 16. So 4 and 16, angle 4 is made with this line and line A, and 16 is made with line E and line B, which means that E is the transversal. So 4 and 16 are on the same side of the transversal. 4 is on the interior because it's in between the parallel lines, and 16 is on the exterior. If that's the case, okay, where one is interior and one is exterior and they're same side, okay, those are corresponding. All right, number 4 asks us to compare angle 4 and angle 13. Okay, so we have the same transversal, we're dealing with the same lines. 4 and 13 are on alternate sides of the transversal, in between A and B, so those are alternate interior. 5 asks us to look at 13 and 12. Okay, so this time around we have a different transversal, since 13 is made with line B and line E, and 12 is made with line F and line B. Okay. So this time B is the transversal. These are on alternate sides of the transversal. They're outside E and F. They're not in between E and F, so these are alternate exterior angles. Okay. Number 6 wants us to compare 16 and 10. Okay, so we're on the same transversal. 16 and 10 are on the same side of our transversal B. They're in between lines E and F, so those are same side interior. Number 7 asks us to compare 7 and 12. We've got a new transversal. Okay. 7 is made with line F and line A, and 12 is made with F and B. So this time our transversal is along line F. Okay. 7 and 12 are both below line F, so they're on the same side of the transversal. They're outside of these two lines, so those are same side exterior angles. Okay, last, it's asking us to compare angle 1 to angle 9. Okay, so when you look at this, angle 1 is made with line A and line E. 9 is made with line B and line F. So these aren't using the same transversal. So these aren't any kind of special angles. These are none. Okay. All right. Next, it says that line E and F are parallel. Get a different marker. And A and B are parallel. And it wants us to find all of these missing angles. Okay. So in your notes, you have a table that lists the angles that are corresponding and the angles that are supplementary when you have lines that are parallel. So the corresponding angles will be alternate interior, alternate exterior corresponding, and vertical. The supplementaries are the same side. So those are same side interior, same side exterior, and then linear pair. All right. So we're starting off with a measure of angle 1 is equal to 120. Okay. All right, so I'm actually just going to go ahead and fill in this whole chart, and then it'll be easy to know what these angles are. So I know that if 1 is 120, 4 is 120, since those are vertical. And then I can solve for angle 2 by subtracting from 180, since 4 and 2 are a linear pair. Okay. All right, so 180 minus 120 leaves us with 60. Now, the easy way to do this is that once you know these 4, you're basically just going to copy and paste that to each of these other 4 sections. Okay? So the reason that we can do that, since both sets of lines are parallel, that means that, for example, 4 and 16, those are corresponding, so those would be the same. We could say that 4 and 15 are supplementary. Okay, so that would mean that 15 is 60. 15 and 14 are vertical, and 13 and 16 are vertical. So you copy and paste over here. If we wanted to go down here, 15 and 10 are alternate interior angles, which means they'll be congruent. 14 and 12 are same side exterior, which means they would be supplementary. So once again, we have that same pattern, 120, 60, 120, 60. Okay, same thing here. We could look at 1 and 8. Those are alternate exterior, which are congruent. You could look at 3 and 5, which are same side interior, so they're supplementary. 5 and 8 are also vertical, which means those should be congruent. Okay, and then we've got 60 and 60. All right, and let's fill in some of these answers. Okay, so once the measure of angle 5, we got that that's 120. Okay. It wants the measure of angle 9, also 120. Notice that 5 and 9 are corresponding, which means that they should be congruent. Okay. The measure of angle 14, we got that that was 60. If you look at 1 and 14, those are same side exterior, which should be supplementary. For angle 6, we got 60. Okay, so if you look at, let's see, 5 and 6, those are a linear pair, so that means they should add to 180, which they do. And then for 4, that would be 120, since it's vertical with angle 1. Okay, number 10. It says, which statements must be true in order to prove that lines B and C are parallel? So basically, what you're doing for this problem is you're using this backwards. Instead of assuming that the lines are parallel and then knowing this information, we're going to determine if this is the correct information that we're given, and then using this, we'll use that to prove the lines are parallel. The only ones that you can't use to prove that lines are parallel are vertical and linear pair angles, because vertical and linear pair are using the same two lines to create those angles. For example, these are what vertical angles look like, and then linear pairs look like this. So they use the same two lines to create those angles. If you're only affecting two lines, you can't be making the third line parallel. Alternate interior can be used to prove that lines are parallel because Okay. It takes two lines and a transversal to create them. So this angle is affecting this line, and this angle is affecting this line. And that's why it can make these, force these lines to be parallel. All right, so with that said, let's take a look at this. So the first one says that the measure of angle 1 is equal to the measure of angle 3. So this is what we were talking about just a second ago. These are vertical angles. Even though it's true that these are congruent, they're equal, the only lines that those are affecting are lines A and line B. Okay? These angles don't even touch line C. You could cover up this part of the picture and those angles are still there. So if they're not even touching line C, they can't possibly be making line C parallel because they don't affect it. So this one is out. All right, part B, it says that angle 1 and angle 8, or sorry, no, angle 1 and angle 2 are equal to 180 degrees, okay? This is the other thing that we were talking about. When you look at angles 1 and 2, these are a linear pair. You could cover up this half of the picture and angles 1 and 2 are still there. That means that this doesn't work to prove that lines are parallel. All right, C, it says that angle 2 is equal to angle 8. All right, now we're getting somewhere. These are alternate exterior angles. They're being made with two lines and a transversal, okay? So these angles are affecting lines B and C. And then it is true that when we have alternate exterior, they're supposed to be congruent. So this works. All right, let's just double check that D is not one of them. So D says that angle 2 plus angle 3 equals 180. Those are a linear pair again. And you can't use those to prove lines are parallel. All right, next let's take a look at number 11. Okay, so it says that line L is the perpendicular bisector of AB. All right, perpendicular bisector means that it's going to be perpendicular with that segment, which it is. Bisector means that it's cutting that segment in half, okay? The other thing that we know, let me get my notes. Based on the perpendicular bisector theorem, any point on the perpendicular bisector is equidistant from the endpoints of the segment. So that means that if I have this point here on my perpendicular bisector, these lengths will be the same. Okay? So that tells me that in this picture, okay, if that's 3, then that's 3. Okay, so let's use this to find some of these missing pieces. So it says, what is the length of AC? Well, we just solved that one. Okay, that would be 3. Which statement must be true? AD is equal to BC. Okay, so if you look at our congruent markings, this is splitting this line in half, making those two congruent. We don't necessarily know that this piece is congruent to this piece. Okay, so that's out. AD is equal to BD. That's true. AD and BD should be the same. BD is equal to AD. That's also true, since they're pretty much saying the same thing, just in reverse. Then it says CD is equal to AD. Okay, that's not true. So B and C would work. Number 12, determine if the lines are parallel, perpendicular, or neither. So I'm going to get a scratch paper for this because we don't have a whole lot of room to work with these. And we're going to have to be doing some rearranging to get these in slope-intercept form. All right, so let's start with x minus 2y is equal to 12. So this equation is in standard form. We need to convert this to slope-intercept form if we want to know what that slope is and what that intercept is in order to figure out if it's parallel, perpendicular, or neither to this one. Okay, so I'm going to subtract x on both sides. So we would get negative 2y is equal to negative x plus 12. Divide by negative 2. So we get y is equal to a negative 1 divided by a negative 2 becomes a positive 1/2. And then 12 divided by negative 2 would be negative 6. So y equals 1/2 x minus 6. So if it's perpendicular, the slopes are supposed to be opposite reciprocals. So this has a slope of 1, this has a slope of 1/2. Even though it did the reciprocal, it did not change the sign, so these are neither. All right, next one. Once again, we have this one in standard form, so we need to convert this to y-intercept form, or sorry, slope-intercept form. So let's subtract minus 1/5 x from both sides. Y is equal to negative 1/5 x plus 8. Okay. All right, another problem. Their signs are the same. If their signs are the same, they cannot be perpendicular, so that's a neither. Okay. Ooh, so it looks like these are both in standard form this time around, so we need to convert both into y-intercept form. All right, so I'm going to subtract 3x from both sides. If you do that, you get negative 2y is equal to negative 3x plus 12. Divide by negative 2, we get y is equal to positive 3 over 2x, since the negatives will take each other out. Okay. And then 12 divided by negative 2 is negative 6. Okay. On the other side, I need to divide everything by 3. So this becomes negative 2/3 x plus 5/3. All right. When you compare these slopes, we changed the sign and flipped the fraction, so these are opposite reciprocals, which means this is perpendicular. All right. Next, y equals 3x minus 1, and then we need to convert this one. So negative 5y is equal to negative 15x minus 10. Divide by negative 5. Negative 15 divided by negative 5 is a positive 3. Negative 10 divided by negative 5 is a positive 2. So when we look at these slopes, they're the same. Their y-intercepts are different, so that means that they're different lines, and they are parallel. Okay. All right, so we need to do a little bit of converting on both of these. So got to divide that by 7. We get y is equal to 4/7 x plus 1/7. Okay. On the other side, subtract that 14x. 8y is equal to negative 14x plus 10. Divide by 8. Y is equal to, let's reduce that fraction a little bit. Okay. So that's a negative 7/4 fraction. Plus, and then it doesn't really matter, but 10/8, and you can reduce that fraction if you wanted to. Okay, so now we need to compare these slopes. So we've got a slope of 4/7 and a slope of negative 7/4. We changed the sign, we flipped the fraction. Those are perpendicular. Okay. FYI, if you see this symbol, the upside down T, that means perpendicular. All right, I'm running out of paper here. I'm gonna have to go to sticky notes. Oh, okay. Last one, we don't have to do any converting. Okay, we've got an x equals 5 and a y equals 5. So, if you learned this in Algebra 1, this is just a little trick, okay, to remember what goes with horizontal lines and what goes with vertical lines. So it's called Hoy-Vux, okay? So H stands for horizontal, O stands for 0, Y equals. Vux, vertical, undefined, X equals, okay? So this X equals equation means that this line is a vertical line with an undefined slope, so it's straight up and down. That Y equals goes with our Hoy, our horizontal, which means that this is a horizontal line with a 0 slope. When you have horizontal lines and vertical lines, those are always perpendicular to each other. All right. Last two questions for the front side. Okay. 13. Write any equation with a slope of 0. So again, our Hoy-Vux can come in handy. If we want a 0 slope, that needs to be a y equals equation. Okay. So we're going to just put, I don't know, you can put anything, y equals negative 1,000. That's a slope of 0. Okay. Write any equation with an undefined slope, not an undefended slope. Correct that little typo. Okay, so once again, Vux, vertical, undefined, x equals. So any x equals equation would do here. So we could say, I don't know, x equals 195,200. Okay. Number 14, it says, given the table and list of slopes, name two lines that are parallel. So we've got AB has a slope of negative 4/3, BC is 4/3, CD 3/4, AD is 4/3. So parallel, you're looking for slopes that are the same. So it looks like BC and AD match up. So we could say that BC is parallel to AD. Name two lines that are perpendicular. So perpendicular lines have to have opposite reciprocal slopes. So we need something that is different signs and a flipped fraction. Okay. So if we look at the slope of CD, that's negative 3/4. So it's changed the sign and it's flipped the fraction. So we could say both BC is perpendicular to CD and AD is perpendicular to that line. Okay. The only one that's not going to play any part here is AB, because it's not congruent to the others, and it's also not an opposite reciprocal for anything, since it didn't change the sign and flipped the fraction. All right, so I'm going to stop the video for the front page. If you want to see the back page, go to the next video.